This is an all-star cast of PhDs, professors, grad students, researchers, and a great example of the talent that comes from deep within the university to solve a real problem in the real world. This time, it's dementia. And to help solve this problem in an incredibly elegant way, please welcome Dr. George Nesher and SafelyYou.
Thank you, Carolyn. Hi, everybody. My name is George Nesher. I'm representing SafelyYou, and we are bringing AI to dementia care. My family is genetically predisposed to Alzheimer's disease. That means I know the pain that comes with losing somebody a little bit more every day, the burden that comes with providing greater and greater care, and the extreme insecurity about how much it will cost. I chose to join the PhD program here at UC Berkeley 3 years ago in the computer science department over those at Stanford and MIT, specifically to work on this problem and to solve and to build this company. But it's not just my family. Dementia is a huge problem. It affects over 8 million people in the United States. It's the single most expensive disease in the United States, and the population is doubling every 15 years because we have no effective treatments or preventative measures. So we specifically are looking at how we can improve care today, specifically in assisted living and skilled nursing communities. In these communities, the utmost concern is keeping residents safe, and the biggest threat to safety is from falls. Falls are the leading cause of hospitalization. The average resident falls 4 times per year in these communities at an average cost of over $6,000 per year paid out of pocket. Moreover, 3 out of 4 fallers experience repeat falls because we have no way of learning from the first fall now to prevent the second. Current solutions all address the general elder care market. They don't address the specific privacy security trade-offs of dementia care. There are wearable devices that might detect when a fall occurs, but they're never used in memory care because residents forget or refuse to wear the devices. There are radar and optical sensors which are currently under R&D and aren't commercially available yet, but even when they become available, they won't be able to show you how a fall happens so you can learn from it. And there are bed alarms which suffer from extremely high false alarm rates in memory care where residents wake up frequently throughout the night. We've been officially endorsed by the Alzheimer's Association because we have the first solution that does work for memory care. We use off-the-shelf video cameras, and we perform deep learning spinning out of the Berkeley AI Research Lab to detect when a fall happens from the video feed. What that means is we can detect a fall from the video, and for under $10 a month, we can send that to a human to review it. With the human review, we can achieve high accuracy very early on because our raw data is video, not accelerometer data. It means that we can confirm whether an emergency room visit is needed right away. The current process is they might not be found until after 2 hours, at which point every unwitnessed fall has to go to the emergency room. So there are lots of visits that are happening that don't need to if we can have the video history. And it means we can look at the video and identify how a fall happened so we can prevent it from happening again. So far, we've collected 50 fall videos, and from just 50 videos, we're already at 80% accuracy. We're collecting on average 1 more video every single day right now through our current pilots. This is one resident who I'll call Frank here. He was falling 3 or 4 times a month in this community. The red shows when he's on the ground. And the staff would just find him next to his bed. He was in a shared room paying $7,000 a month. And they didn't know how the falls were happening. This is the current state of the art. This is current practices. But when you look at the video, you see he's falling almost the exact same way every time. His walker is getting caught on his roommate's bed, and he's getting trapped there and not able to make it to his own bed. So by identifying this cause, we can recommend moving him to the bed closer to the bathroom, and he doesn't fall again after that. Through practices like this, in our first community, the fall rate went down by over 80%. This is really huge and really exciting, but it's also very preliminary. One of the big reasons it's really exciting is because this is the first quality metric used by Medicare to determine how much to reimburse skilled nursing communities. We're now seeking to confirm this result and to build the data set we need to perform high accuracy detection through the deep learning paradigm through 11 unpaid pilots. We were really excited to have 100 residents enrolled and to have 3 major senior living providers decide to join us. These providers are part of networks representing 130 communities or the potential for $3 million in recurring revenue for our service. This is 1/1000th of the population of the US dementia care. Our go-to-market strategy is to deliver this high-margin service. We figured out how to install the system in these communities in under a day, even if there's no wireless infrastructure already in place. We provide these services for $100 per month. There are many other services we could provide because this data is so expressive and the need is so great. For instance, detecting when a bedridden resident hasn't been turned every 2 hours to prevent the expensive and painful bed sores. We grow through a land and expand strategy, piloting with one community within a large central network and expanding throughout the centralized providers. And we're low risk because these communities want a 1-year contract. In 1 year, our lifetime value is already 10x our customer acquisition costs, and really they expect to use it for 5 to 10 years. Unfortunately, the market is huge. There's a lot of people affected. Particularly in Japan and China, we see lots of need. But we focus now on the US managed dementia care market, where 1.5 million individuals live today, and the population is doubling every 15 years. If we continue to get 1/3 of each community, as we have so far, this is 500,000 people and the potential for $1.2 billion in recurring revenue for our service. And this is not including at some communities where we get 50 to 75%, and we're learning exactly how we engage the community so strongly. We're an all-star team. We have leading researchers from Berkeley, from DeepMind, and Stanford. They're all personally affected by this terrible disease and working together to make it better. We're Google Hackathon winners. We've been featured in MIT Tech Review. We're endowed chairs at UC Berkeley. And we're really committed to solving this problem. In the last few months since leaving the university in January, we've won 3 awards with over $500,000 in non-dilutive funding. And we've assembled an all-star team of advisors representing key clinical experts, policy experts, customer advisors, startup executives, and one of my previous PhD advisors, Trevor Darrow, who's very well known in the deep learning space. So we're now announcing today the first investment opportunity in our company. We're raising a seed round of $1 million to develop a turnkey product. What that means is taking the off-the-shelf hardware we use now, pulling it into one solution, and building the data set we need to detect an arbitrary fall in an arbitrary room. To do that, we need 100 facilities enrolled from the 11 we have now. Those 100 facilities represent 1,000 residents falling 11 times a day. We expect to get to that point by January, and then build that data set out to the point where they're all subscribing customers by Q3 2018. Thank you very much.